Good morning. Let us see about engineering geology subjects in Unit 3, Petrology. Petrology, definitions of petrology. Petrology is a branch of science dealing with various aspects of rocks, such as their formation, classification, and occurrence. That is called as petrology. Petrology is deals within the rocks. Okay. Then classifications of rocks. Classifications of rocks, basically it's classified into three categories, that is igneous rock, sedimentary rocks, and metamorphic rocks. Now let us see some technical words in petrology. First we see about magma. Magma, the whole molten material occurring beneath the crust of the earth, is called magma. And lava. Lava, when this magma comes out from the earth, interior to the surface of the earth is called magma. And lava is classified into two categories, that is black lava and ruby lava. Okay. The branches of petrology deals with various aspects of the rocks, such as origin of the rock, texture of the rocks, and structure of the rock, occurrence of the rock, mineral composition of the rock, physical properties of rock, and finally chemical composition of the rocks. We see about this one by one. Next thing, classification of rocks. Rocks is classified into majorly three categories. One is geologically structures based, another chemically based, and another one is physically based. First, it's classified into geologically. They are again divided into three categories. One is igneous rock, sedimentary rock, and metamorphic rock. Chemically based, it's classified into three categories: siliceous rock, argillaceous rock, and calcareous rock. Physically, it's classified into three categories: stratified rock, unstratified rock, and foliated rock. Okay, these are all the basic classifications. Igneous rocks again classified into three categories. One is plutonic rocks, hyperbasalt rock, volcanic rock. Sedimentary rock classified into three categories: plastic deposits rock, chemical deposits rock, and organic deposits rock. So basically, rocks are classified into three main categories: geologically, chemically, physically. And geologically is divided into again three categories: igneous, sedimentary, and metamorphic rocks. Okay. Next, igneous rocks. This is the example of igneous rocks. Igneous rocks is origin of igneous rocks is volcanic rocks. That is cooling and crystallization of lava. But the best example of the volcanic rocks is Deccan Traps in India. That is the best example of igneous rocks. Next, the plutonic rocks. Plutonic rocks is available between 7 to 10 kilometers below the Earth's surface. It's the cooling process, and rocks possesses coarsely grained crystalline structure. The best example of plutonic rocks is granite. We all know all about very well about granite, okay, because we are using the granite in flooring, in construction works. That's why we know very well about granite. So granite is the best example of igneous rocks and is the one of the type of plutonic rocks. Next, hyperbasalt rock. Hyperbasalt rocks is generally up to 2 kilometers below the surface of the earth. It's having mixed characteristics of volcanic rock and also in plutonic rocks. Porphyrics of various composition are examples of hyperbasal rocks. Next, geological classification of sedimentary rocks. Sedimentary rocks is the deposition of mineral or organic particles at the earth's surface. Examples of sedimentary rocks are sandstone, siltstone, and shale are the examples of sedimentary rocks. Sedimentary rocks are residual deposits remain in the site of origin. Sedimentary deposits away in suspension and depositors. Chemical depositors is a physiochemical process such as evaporation. Organic deposits agencies of organisms is the types of forms of sedimentary rocks is breccias, conglomerate, sandstone, and shale. Breccia. Breccia is the machinery formed of sedimentary rocks closed in rhodite. Conglomerate. Conglomerate, these are the sedimentary rocks or elastic nature and belonging to rhodesious group. Sandstone. Sandstone are the mechanically formed sedimentary rocks or arenaceous groups. These are all the forms of sedimentary rocks. Next, metamorphic rocks. Metamorphic rocks is the best examples is marble, quartzites, and marble. Okay, marble is the best example of metamorphic rocks. Metamorphic rocks is formed by metamorphism. So what is meant by metamorphism? Metamorphism may be defined as the physical and chemical alteration of solid rock that transform their texture and structure, mineral composition in response to change their environment conditions within the earth. That is called metamorphic rocks. Metamorphic rocks is the changed the forms of chemical and physical properties of igneous or sedimentary rocks. That is called as metamorphic rocks. Metamorphic rocks are what are the changes in metamorphic rocks? That is crushing of grains. Okay, that is the changes of sedimentary rocks. For sedimentary rocks, it gets changed or transformed into crushing of grains. That's the coarse grain to medium grain or fine grain. That is changed into metamorphic rocks. Recrystallization. The crystallization forms of the structure is changed or converted. That is called recrystallization. Interlocking of grains. Grains interlocking increase the grain size and development of parallel alignment of elongation flat grain. What are the causes of metamorphism? Metamorphism form. What are the reasons? The causes of metamorphism is pressure, heat, and circulating fluids. That is the main reasons of metamorphism. Next, chemical classification of rocks. That is siliceous rocks, argillaceous rocks, and calcareous rocks. Siliceous rocks is the sedimentary rocks. For example, gypsum, rock salt, chet, taveritin. These are all the examples of siliceous rocks and argillaceous rocks. Next, calcareous rocks. These are all the chemical classifications of rocks. Next, siliceous rocks is their predominant material and hardened durable. For examples, granite, quartzites are the examples of siliceous rocks. Siliceous rocks is a hardened durable. It's having high compressive strength. Next, argillaceous rocks. Argillaceous rocks is having more quantity of clay minerals. They are having clay properties and it's having dense and compact in argillaceous rocks. For example, slates, laterites are the examples of the argillaceous rocks. Okay. Next, calcareous rock. Calcareous rocks is having more content in calcium carbonate. So that's why it's in light colors. Then durability depends upon the constituents. Limestone, marbles are the examples of the calcareous rock. Based on chemicals, siliceous rocks, argillaceous rocks, and calcareous rocks. Next, physical classification. Physical classifications based on stratified rock, unstratified rocks, and foliated rocks. Next, classifications of rocks. How do rocks form? Rocks formed in volcanic eruptions of lava and magma, and then it's formed into cooling process that gets igneous rock. Igneous rocks it's get these structures that is sediment, and it is formed as sedimentary rock. Sedimentary rock get metamorphism, then it is changed into metamorphic rocks, and again that metamorphic rocks converted into high pressure and heat, then it is changed into lava. Again, it is as igneous rock. So it's a rock cycle. Okay, so first we get igneous rock. Igneous rock converted due to some physical properties and chemical properties, and it is converted into sedimentary rock. Sedimentary rocks is changed into metamorphic rocks. Okay, metamorphic rocks converted into igneous rocks. This is the rock cycling process. Okay, then extrusive igneous rocks and then intrusive igneous rocks. Extrusive igneous rocks, let us see about in first unit at the structure, that is crust, mantle, and core. Okay, so this is the intrusive and extrusive igneous rocks. It is in magma availability in crust, lowest portion, and highest portion, higher portion. Okay, let's see about origin of igneous rocks. Igneous rocks are formed due to consolidation of magma, and sedimentary rocks are formed due to weathering and erosional process of igneous rocks, and metamorphic rocks are formed due to metamorphism of sedimentary rocks. So already we see what is meant by metamorphism. What is the source materials of rocks? Magma is the main source of the igneous rocks. And igneous and metamorphic rocks are the main sources of sedimentary rocks. Igneous and sedimentary rocks are the main source of main formation of metamorphic rocks. That is clear. Magma is the basic source of formation of igneous rocks, and igneous and metamorphic rocks are the source of materials for the formation of sedimentary rock, and igneous and sedimentary rock is the source of material for the metamorphic rock. So basically, igneous rocks is the main source of sedimentary and metamorphic rocks. Lava is the main source of for all these three types of rocks. Interlocking structure. Igneous rock shows interlocking structures of mineral grains and no interlocking structures in sedimentary rocks. Some interlocking and somewhat not interlocking in metamorphic rocks. Cementing media, that is the bonding media. No cementing media between mineral grains of rocks in igneous. Many of the sedimentary rocks having cementing media binding the mineral grains. No cementing media present in metamorphic rocks except quartzite. Okay, so no cementing media in igneous and metamorphic rocks except quartzite, and many of sedimentary rocks having cementing media between the mineral grains. Composition. Composition of igneous is major part of lava, and sedimentary depends upon the composition which is formed in igneous rocks, and metamorphic rocks depends upon the composition of their parent rock, whether it is sedimentary rock or it is the igneous rocks. That is the parent rock of metamorphic rocks. Structure of these three types of rocks. Igneous types of structure is sill and dike. It's a sheet structure, Catholic, columnar, low polyp. That is the structure of igneous. And sedimentary. Sedimentary is the stratification, graded bedding, cross bedding. This is the formation of sedimentary rock structure. Metamorphic structure is hystosis, genesis, and foliation. Then texture of three types of rocks. Igneous rock texture is hollow crystalline structure, medium to coarse grained structure, adral structure, and subadral structure like that. And texture of sedimentary is plastic and non-plastic structure, granoblastic structure, idioblastic structure. And texture of metamorphic is crystalloblastic, palimpsest texture, granoblastic, etc. These are all the texture of rocks. Stratification. No stratification in igneous rocks and stratification found in sedimentary rocks. No stratification in igneous and metamorphic rocks. Then physical characteristics of structures. First thing, compressive strength. Let us test about compression strength. Compression strength is generally higher than sedimentary rocks in igneous. Less than that, igneous and metamorphic rocks is sedimentary. Higher than sedimentary is metamorphic. Finally, igneous rocks is having high compressive strength and metamorphic is having somewhat less compared to igneous, and sedimentary is less compressive strength from others. Next, specific gravity test. Specific gravity test is igneous is higher than sedimentary rocks. So igneous and metamorphic rocks having higher compressive strength compared to sedimentary. Sedimentary has less compressive strength. Compressive is less, sedimentary is comparative to other two, it's having less compressive strength. For example, granite, igneous example or rock is granite. Granite having 1000 to 2500 kg per centimeter square, and sandstone. Sandstone is sedimentary rocks example. It's having 200 to 2000 kilogram per centimeter square, and genesis is the example of metamorphic rocks. It's having 500 to 2500 kilogram per centimeter square. When we have find the compressive strength in a compressive testing machine, okay, we have find a lot of tests like compressive strength, tensile strength, hardness, water absorption test, porosity, abrasion coefficient, toughness index, specific gravity, weathering resistance, etc. First, the compression to compressive strength. Compressive strength is expressed into C, that is load failure divided by load area of the surface, that is load by area is compressive strength. We are finding this compressive strength in UTM testing machine. And tensile strength. Tensile strength of the next one is specific gravity. specific gravity test. Next one is tensile strength test. Tensile strength test is found in Brazilian test. It's a Brazilian equipment. In granite, we are having 7 to 25 Newton per mm square. And then sandstone, that is examples of sedimentary rocks, that's having 4 to 25 Newton per mm square. And marble is having tensile strength of 15 Newton per mm square. And quartzites is having the tensile strength of 16 to 30 Newton per mm square. Okay. Next, hardness. Hardness test. Hardness is defined as the resistance offered by a stone specimen to any external force that tries to scratch it. We are having more scale numbers 1 to 10. Then 10 is the hardness number of diamond. And for example, talc having hardness number 1, and gypsum having hardness number 2, and calcite having hardness number 3. Okay, this is the examples. Next, water absorption test. Water absorption test is finding from the equipment with the help of pycnometer some bottles, take some measured amount of rocks, like whether which rock we are finding test, we take the type of rocks, that is some amount of rocks with a measuring, and it is immersed in water for 24 hours. After that, again we take weight and compare it to these two weights. That is the water absorption test of rocks, water absorption test. And sandstone and limestone is having 10% of water absorption, and first class bricks having 20% of water absorption. Next is specific gravity test. Specific gravity igneous higher than that of sedimentary rocks, and sedimentary rocks less than that of igneous and metamorphic rocks. Metamorphic is higher than the sedimentary rocks. Next, organic process. So, igneous and metamorphic having no organic process involved in the formation of igneous rocks, and organic process are involved in the formation of sedimentary rocks. It's fossil content. No fossil content found in igneous and metamorphic rocks. Some varieties have some types of fossil content preserved in sedimentary rocks. Metallic minerals. No metallic minerals found in sedimentary rock, and some metallic minerals are associated with some varieties of rocks like igneous and metamorphic rocks. Examples for rocks. Igneous, examples of granite, dolerite, basalts, gabbro. These are all the examples of igneous rocks. And sandstone, limestone, shale. This is the examples of sedimentary rock, marble, schist, granite, slate. These are all the examples of metamorphic rocks. Uses for these rocks. Generally, rocks are used in building construction, like coarse aggregate, somewhat. So igneous rocks is used as road metal coarse aggregate, and sedimentary rocks is used for building stone, coarse aggregate, raw materials, and metamorphic is used as a slab, it's a kadapa slab, like it's a plate types. It's used also building stone, road metal, concrete aggregate, and metamorphic rocks is also used as monumental structures made. Next, engineering properties of rocks. Already we see about these types of tests, like compressive strength, tensile strength, hardness, water absorption capacity, porosity, abrasion coefficient, toughness index, weathering resistance. This is the compressive strength. Already we have seen. Next, Tensile strength. Tensile strength is also this C. Next, hardness. Next, water absorption capacity and porosity. Porosity is the ratio of volume of pore spaces to the total volume of rock or soil. This porosity of the specimen is equal to volume of pore spaces present in specimen divided by total volume of specimen into 100. That is called porosity. Porosity, for example, granite, we are having porosity value 0.1 to 0.5 percentage, and sandstone having 5 to 2.5 percentage, and marble it's having 0.5 to 2 percentage of porosity. Next is abrasion test. Abrasion means is the resistance offered by a stone against rubbing action. That is called abrasion. Abrasion coefficients is used. Abrasion coefficients value is used in road metals, building metals, and tunnel metals, dam constructions, etc. Equipment is used in abrasion test is Doris abrasion testing machine. Abrasion value is the less than 2 percentage is the safe of the metal. Next, toughness index. Number of blows of load from a constant height applied to the stone specimen without undergoing failure. That is called toughness index value. So toughness index value is less than 1.5. Okay, this is the toughness index value. Next, specific gravity. Specific gravity is weight of stone of sample in air divided by weight of equal volume of water into density of water. Density of water is value 1. This is called specific gravity. Specific gravity find it. They are using pycnometer bottle. This is the pycnometer bottle. The portion is called as a conical cap. Specific gravity of some examples: granite having 2.6 to 2.7, sandstone 2.2 to 2.8, marble 2.4 to 2.7, quartzite 2.6 to 2.8. These are the specific value of like this metal. Specific gravity having no unit. And weathering resistance index. Weathering resistance means resistance offered by stone sample to weathering impact. It is indirectly known by doing acid test. Next, types of igneous rocks. Then let's see about the next classes in igneous rocks descriptions. Examples: granite, scoria, pumice. What is the origin of granite? Texture, phreatic, mineralogy, etc. Okay. Thank you.